Hello, everybody. Welcome to the Audio Precision webinar. Today, we will be discussing available methods of automation using the APx500 API, and Ben Kilada will be leading that presentation today. Ben is a technical support and applications engineer at Axiometrix Solutions, specializing in supporting audio precision and GRASS sound and vibration products. My name is Jennifer, and I'm the producer of this event. Before we get started, I just want to go over a few housekeeping items. First, please note that this session is being recorded. Secondly, we welcome questions, which you can do by typing in your questions in the Questions tab, which is on the upper right-hand side of your screen. Lastly, a copy of this presentation has been added to the handout section, which you can also find on the upper right-hand side of your screen. Ben has a lot of valuable information he wants to share with you today, so I'm going to hand it over to Ben now.
Awesome. Thank you, Jen. Welcome, everybody. I'm glad you all can join us. As Jen said, my name is Ben, and I am on the technical support team for Axiometrix Solutions, specifically for audio precision and for GRASS acoustics. And I live in Portland, Oregon, here in the beautiful Pacific Northwest, where we manufacture all of our AP equipment. So I'm hoping to hit on three primary objectives today. Obviously, this whole session as a whole is primarily about the API, but I will start off briefly by making sure that everybody is aware of both the graphical and the sort of code-based automation workflows in APX software. Then we'll dive into understanding the API capabilities in more detail, looking into its key features and functionality. And then lastly, where we will spend most of our time is in examining the API structure, specifically through some practical examples, code snippets, and design insights. So please submit. You should see a questions window in the go-to software. So please submit your questions along the way, and then we'll reserve some time at the end to address them. As we're going through the slides, don't worry too much about memorizing particular or screenshotting specific APIs. You can if you want, but I think it would be to your advantage to focus more on the concepts than on the specific APIs, because we will be sharing the slides with you all afterward via email, and actually I think you may already have access in the handout section of GoTo. I'll also take this opportunity to mention that our global workshop series is returning this year. For those of you who are just new to APX500 in general, not just the API, or maybe who want a refresher, these are sort of intensive, all-day, hands-on trainings that we host in different cities and countries around the globe. So if you're interested in this, keep an eye on your email inbox, as well as the events page on our website, because our schedule should be going out next week. All right, let's dive in. So as I'm guessing most of you already know, our analyzers are all controlled by APX500 software, and that software has two user interfaces, the graphical user interface and the application programming interface, or API. Inside of the graphical user interface, you have actually quite a long list of features that you can use related to test automation. So I've listed some of them here. So you have the ability to sequence any number of measurements together for one-click execution. And then you can apply pass-fail criteria, what we refer to as upper and lower limits, on any of the graphs in your sequence. If you're testing a Bluetooth device, you can do things like automate pairing and connecting to a device based on MAC address or something else. You can automate data export to disk, as well as generation of detailed reports. You can log quite a large number of statistics to a CSV file. This is primarily useful for production test applications. You have the ability to integrate user prompts, which instruct the operator to perform some kind of action with an optional image and also text, or you can ask the operator to input some text. You can also add multiple sequences to one project. So as you can see here in this project, we have one sequence to calibrate the loudspeaker and the other to actually test the device. And then lastly, there is the ability to use the auxiliary I/O on the back of our analyzers to either, for example, you can start a sequence on the foot press of a pedal, or maybe what you want to do is turn an LED ring to green when your sequence passes. Another useful feature that's built in is the program step. And what this allows you to do is execute, or run any executable file from any point in your sequence, or also before the sequence. So here you can see we have a program step that I've added before my sequence, and I can tell the program step exactly which file that I want to run. In this case, it's the batch file. If you're writing Python scripts, you can call Python with a path to your .py file. And then you can pass whatever arguments and working folder you like to the program. So in this example screenshot here, I just show that you could use this to boot your device if maybe it's connected to the PC via a serial or USB connection. But you can use this for any purpose you like. We also have the ability to lock project files. So if you want to restrict the operator from being able to change any settings, this is when this feature comes in handy. And optionally, if you check the production test box when you're locking the project, then the user interface is actually further restricted down to this one window. And in this window, you have an optional banner, some optional text that you can display, and then a button for each sequence inside of your project file. When you click on a button, it will pop open the progress window, and where again you can have an image, and then it will show the status of each measurement as the sequence executes. But let's say you're already familiar with all these features, and none of them work for you, because what you want to do is actually integrate control of your analyzer into some other existing application that you're developing or that you've already made. Let's say, for example, you are making a production test controller application to control all of the various hardware on your production line at each test station. Another example for R&D might be you just want to write some kind of loop that is running continuously and logging maybe a level reading every 2 seconds. For that kind of thing, you will need to use the API. And the API, the good news is the API supports all of the same software functions across all of our APX analyzers. And it works with any .NET framework language and is available at no additional cost. All the commands in the library are compiled into a .NET framework library, a DLL file, and this DLL is installed with APX, and it's also versioned based off of the release of software that it relates to. Once you reference that DLL in your scripts, then you can instantiate APx500, after which all of the APIs will be available to you. So when you instantiate APX, it will also launch the software as well if it's not already open. If you don't have access to an analyzer currently, maybe you loaned it to a colleague, then you can still make progress programming. What you see on the left side of your screen there is the prompt that you get when you launch APX software without an analyzer connected. And what you'll see there is it allows you to emulate any of the models of analyzers that we sell in what we call demo mode. And the same thing is available to you when you're programming. So all you have to do is, in your instantiation call, after the argument for operating mode, you put in the demo mode argument and then insert the analyzer model that you want to emulate. If you're using Python or MATLAB or V, then you will need to make sure that you reference both the primary API library as well as API2, or what we call the API wrapper. And what this does is it reveals additional APIs to these languages that maybe support less of the .NET framework features. So reference both DLLs and then use APx500 underscore application to instantiate rather than just APx500. We do also have a COM or ActiveX library that we call API3. And then in this screenshot here, this example is Microsoft VBA. So as you can see, just like with the other API wrapper, you need to reference both the main API DLL and then the COM wrapper as well. We do also have a LabVIEW driver. So if you like to work in LabVIEW, you can do so with APX. But just a couple things to know if you plan to use the driver are that A, the driver version that you download and install from our website needs to match the APX software version that you're running. And then B, it is software control. It's not a Visa driver or anything like that. So these are, when you run the installer, it will place a collection of VIs onto your PC. And these VIs are implemented using our API. And then once that's installed, if you go into the functions palette in LabVIEW, you should see these VIs. All right, so let's do a quick demo here. I'm going to switch over to Visual Studio. You don't have to use Visual Studio, but just as an example. And what we're going to do here is just very quickly show what it looks like to actually create a new script and reference the API. So as I mentioned, we only support .NET Framework, so we will type that in here to filter the list. And for this example, I think what I will do is make a console application. We'll give it a name, All right, so you should all see Visual Studio. The first thing you always have to do is add the reference to the DLL library. So in Visual Studio, the way that you can do that very easily is right-click on References, click Add Reference, go over to the Extensions list, and then check the version of software that you want to control. And then if this were Python, you would need to make sure you reference the wrapper as well. So there it is, version 9. And then since this is C#, I also need to add a using statement. After that, we can instantiate our APx500 object. This is the C# syntax. And then from there, we have the whole API available to us. So if I type APX, it will find our object here. And now you can see nested under APX are all of the APIs. So just as an example here, I will type create new project. And now we could begin programming. So every setting, every button in the graphical user interface has a corresponding object in the API. And there is the root object, which is APX, and then every other object is nested under that root. And every object also has APIs that govern their behavior. Those APIs are exposed as properties and also methods. When you install APX, it also will install what we call the API browser. And this is one of the best ways that you can search the entire API to look at all of the objects, properties, and methods in sort of a tree view structure. So once you find a property that you're interested in, if you click on it, you'll get both a summary of what the property relates to, as well as an indication of the data type of the property. And if it's a type enum or enumeration type, then if you click on this, it will link over to the related enum on the enums tab. So this will show you what values this specific property accepts. Similarly for methods, if you're looking for a method, this will list all of the different variations of arguments that that method can accept. And if you click on one of these, it will describe what the method does, as well as provide a description of each argument. So APX is split into two different operating modes. You might have noticed, if you haven't even used it, there's this drop-down on the top right to switch between modes. And similarly, the API is divided into two different buckets. When you are instantiating APX, this is a good time to pass in the operating mode that you either want it to switch to or launch the software into. And I would also take that opportunity at the very beginning to also set the visibility state of the app. Within sequence mode, you have three general categories of APIs. You have your signal path setup configuration, you have measurement configuration, and then you have your sequence related API, such as for getting acquired data and pass-fail status and so on. So when you're doing configuration of measurements, it's important to first make sure that you show that measurement. Otherwise, you will get an error related to that, that item not being currently visible. And this is just like the graphical user interface, right? If you tried, you can't change the generator level and frequency response until you click on the frequency response measurement. However, for the other measurements, there's no need to show anything first. You can always use the signal path setup APIs, and you can always call into the apx.sequence APIs. There are objects to configure each of the measurements in sequence mode, and the names of the objects, which are directly under the root, closely correlate to the names in the add measurements pick list. So before you can use the APIs, you need to first add the measurement. And to do that, you need to pass in the signal path name that you want to add it to, as well as the measurement type enum value. Inside of measurements, you have different kinds of results. So you have the default input one results, which all have dedicated objects for their configuration as well, directly under the measurement. But there are also derived results and input two results if you have a secondary input interface specified in signal path setup. And for these kinds of results, you need to, rather than there being a dedicated object, you need to index into the graphs collection with the name of the graph. Something to note about this graphs collection is that it's a collection of generic graph types. So it doesn't contain information related to whether the graphs it contains are XY graphs, meter graphs, or another type. So you might find if you're looking for a specific API related to, say, an XY graph, as in this case, you might find that that API is missing. So what you have to do is first cast the result to the appropriate type. The same is true for derived results. Here's an example. So we have the smooth derived result, which is derived from the RMS level. And what I do here is create a variable and assign it to the smooth result from the graphs collection casted to a smooth result. And then from there, I can access the octave smoothing setting. So if you want to get data directly from a measurement, in other words, not through running a sequence, but directly through the measurement APIs, first of all, you need to make sure you show that measurement, as we discussed. But then afterward, if you want to get all of the data values, you can use these get all XY values APIs, and also for meters get values. And what this will do is return a double array containing all of the information, all of the data points on the graph. If you want a specific number of points, we can do that too. Just use the number of graph points property to limit the number of points, and it will decimate down. And then use get X values and get Y values APIs instead. If you want to export to disk, you can do so like this, and you can either export all points or a specific number of points. If you want to put all of the results in one measurement, in this case, acoustic response, into a singular data file on your hard drive, you can do that by using the export data method on the acoustic response object. Just note that if you're going to use this API, that you should first delete any results that do not contain data. And in this case, this can happen for different reasons, but in this case, it was because these results are only valid with the fast sweep stimulus type, and I had the chirp selected. When you run a sequence, so what we've been looking at is how to get data directly from measurements. However, when you run a sequence, it will collect all of the data from all of the checked measurements, including pass, fail status, failure codes, and messages into this APx.sequence collection. And you can control how many data points are picked up into this collection. So from the graphical interface, you go into the data settings window, and this needs to be done per measurement. That will bring up the graph data settings. And then from the specification column, you can select either all points or a specific number of points. And that will control what's picked up in the sequence. The same exact thing can be done from the API using the export specification property. You can also create a custom specification which says I only want data between this and this point on the x-axis with, let's say, logarithmic spacing and a certain number of points. And so I've included some example code for that here, so you can refer back to this later. Units are picked up directly from the graph. So if you want to change the unit in the sequence results, you'll need to use the measurement APIs to first select the correct unit. So once you've run your sequence, you can index into this collection, first of all, putting the signal path name in square brackets, then the measurement name within that signal path, at which point you can access various APIs, such as APIs related to sequence steps, to failure behaviors, and then perhaps most importantly to the check states of results as well as the acquired data. Here is an example. So looking at the same measurement we were on the previous slide, the first thing that we're doing here is setting the check state on the RMS level result to true. Then we run the sequence, and from there we can get all of the X and Y values, in this case on channel 1, from this result and store them into a couple double arrays. And I've also included an example for a meter result here. Okay, so I'm going to switch back into Visual Studio, and the first thing that we're going to want to do here is set our operating mode to sequence mode. From here, we can configure our signal path. So I will go ahead and set my output connector type, just to give you a couple examples here. So we'll do unbalanced output and go back into signal path setup. This time we'll go to input connector dot type equals input connector type dot, we'll do analog balanced. Right, I'm going to add a measurement now. I'll add a continuous sweep. So APx dot add measurement. It wants the signal path index you can see there's different variants of this method here we can switch through that take different arguments. We only have one signal path in a default project, so I'm going to just use the first one in the list. And then for measurement type, we want the continuous sweep. Adding a measurement makes it active, so we can use its APIs. So you can check results to include it in a sequence from your measurement APIs as well. So since we're already here, I'm just going to go into the level result and set the checked state to true. After that, we can run our sequence. Oops, I need to do this. And then the last thing we need to do here is create a couple double arrays. So we'll start with x values equals, we'll go into our sequence collection, we'll open a square bracket, and we'll put the signal path name. So if you go into APX software, you can see the signal path name. We want this exact string as well as the exact string of the measurement that we're adding. So we'll do signal path 1, continuous sweep, and then we'll go into the sequence results. And this is, it will be, so if I add a continuous sweep here, it's RMS level. So we'll type that in, dot get x values, and it'll ask for the channel. I will say channel 1. Then as a shortcut, I recommend just copying the entire line and then just modifying a couple things to get the y values. And that's it. That's the complete sequence mode script that shows how to sort of instantiate, reset the state, access a couple signal path settings, add a measurement, include a measurement in the sequence, and then get data values from the sequence. So bench mode is pretty straightforward. You have a bucket for every panel in the software, basically, where you can find APIs related to those settings. But one of the unique APIs that bench mode has, one of the more useful ones too, is this one called get settled meter readings. And what this allows you to do is at any time, regardless of which measurement you're looking at, you can use this API to get any number of settled readings at the same time. And the way it works is you need to create an array of meter types containing all of the readings that you want to take. You pass that into the method, which will return a collection of results. And from there, you can index into the results, again, based on meter type to get the desired values. In bench mode, you don't have to show a measurement before you utilize its APIs. However, if you do run a measurement in bench mode, something that's distinct from sequence mode is that the start call in bench mode actually spawns a new process. So the start, what that means is this start call is not blocking, and your script will immediately go to execute the next line, even while the measurement is still running. So that's useful in some cases where you want to multi-thread. and maybe indicate progress to the user. But if you want to make it wait, what you can do is right after you start the measurement, add some kind of loop so that while the isStarted flag is set to true, it will actually wait, in this case, 100 milliseconds at a time, until that flag goes false before continuing. And there's also a number of APIs that you can use to query if any error occurred the last time the measurement was run. All right, so what I'm going to do here is comment out the sequence mode code, and we will make a little bench mode example. So first thing is to switch the operating mode. From there, we can go into the bench mode APIs and set up signal path setup. We have just setup, as we saw. I will do the same thing that we did before and set the output connector type, as well as the input connector. And let's go ahead and write some code to take some settled readings. So the get settled meter readings API, this information that you see here is in the API browser as well, by the way, if you're not using Visual Studio. So as you can see, it takes an array of settling meter type. So before we can call this, we need to create this array of the meters that we want to take. So what I'm going to do is create an array of meter types equals, we will pass in, let's just do RMS level and maybe THD plus N. Now we can call this method with that argument, and we need to make sure we capture the output of this method. It's an iSettled result collection. So we will create a new variable, results, and assign it that value. And then from there, the last thing we need to do is create our double arrays to store the data. We'll call this one level values equals results, index into there with the meter type dot get values. And here we want to do VRMS. And then I'll do the same thing for the other meter. So new double array THDN values equals results, index into it by the meter type. We want THDN ratio dot get values in dB. So regardless of which operating mode you use, I always recommend that people use project files if they can. And you know, sometimes you want to explicitly type all of the configuration, and I understand that, but it can also save a lot of time finding APIs and also writing out the APIs, because all of this code, and it can be much more than this, it's essentially condensed down into these two lines. And project files are forwards compatible. So if, for example, you saved a project file in version 7, you could load that project file back in version 7, 8, 9, or any future version of APX software. Another thing to know is that whenever you exit APx500, your connected analyzer reboots. And if you try to restart the app from the API while it's still rebooting, it will think that, basically it will think that no analyzer is connected, and it will launch the software into demo mode. So the way to prevent that is to add at least 25 to 30-second wait period after the exit before you restart APX. And I would also recommend that you make use of this is demo mode flag as a kind of safety net. That way, if it did launch into demo mode, you could catch it and then exit the process and restart. Oftentimes when you're programming, it's handy to store the reference to an object within a variable. That way you can write in shorthand. You don't have to write all of this out every time. You also might get some performance gains because in this case, we wouldn't be casting to a smooth result every time. However, if you wait too long without using this variable at all, this reference, then Windows will actually think that that object is not being used and that it's wasted memory. And it will come along automatically without your input and just delete that reference from memory. And that will cause this API to result in an error. So what I recommend as a good practice is, for example, let's say you have a function where that's called start tests, and what I recommend is at the top of your function, if there are any object references that you've stored in variables, to reinstantiate them before you utilize them. If you are wanting to deploy APX tests on remote computers, network connected computers, you might, if you see an error like this, it's because the app was not launched in what Windows calls a user interactive mode. And so what you will need to do is use RDP, the remote desktop protocol, or other methods to ensure that you first create a user interactive environment that the application can launch into. And this might involve making sure that if you're doing continuous integration, making sure that your agents run interactively and not, for example, as a Windows service. If you're updating your software, say you've been using version 8, you want to go to 9, note that the API is revised with each major and minor release of software and not with the point releases. So what you'll need to do at minimum is delete your old API reference and add the new one. There's a chance you might see, if you're jumping, particularly if you're jumping a number of software versions, there is a chance that some APIs will have gone obsolete. If that's the case, you'll get compile time errors, or in Visual Studio, it will just indicate the error. And your best path forward is to use the API browser, specifically these two tabs, to see exactly what APIs have gone obsolete in each version, and then what replacement API we recommend. And if you have any questions, you can always email us and we'll help you out. I will also mention, if you don't even have a license for the new software yet, maybe you're still evaluating, you can download that software for free and then update your API reference and just kind of get a handle on how many changes will be required. So you can do that without purchasing. If you intend to share your program or script with a colleague or with another team, then you need to make sure that your software licenses for everyone are in order. And what that means specifically is everyone needs a license for the same software version, and then also a license for each measurement that you use in your program. And these licenses track the analyzer, not the PC or the user. There are a large number of APIs that you can use to query the available hardware and software options in a connected analyzer. So this is a kind of safety net that you can use. Maybe you can show an error if the required option is not available. All right, let's look at a few helpful materials. So I've gone ahead and made a few example scripts, just kind of as a starting point for a few popular languages. So if you just copy this and paste this into Python, it should work. So hopefully that's helpful. You can refer back to later. Also for C#, an example, and or MATLAB as well. If you're using plugin measurements, you can control plugins from the API. We didn't have quite enough time to cover that here today, but there is a complete instruction set available on our website at this link. And then I've included a number of links to other helpful materials as well. And I'll point out that if you are going to use Python, make sure that you read this guide first, because there are a couple steps that you need to do to make the Python environment work with our .NET-based API. All right, so we're going to move to a time of questions and answers, and we'll take about 10 minutes for this if we have questions coming in. So let me pop open my list here and see what we have. So here's a first question from Anthony. He asked, if you change the name of a measurement, such as continuous sweep for ohm, how is that written in the measurement typeline? So I think what he's referring to is when you're indexing into the sequence collection for data, you need to put in the signal path name and the measurement name. That name, if you rename a measurement, you should put the new name, whatever you typed in, into that as the index in that API. So it's whatever custom name you give it. Let's see. We have a question on LabVIEW. Somebody has two different versions of the API installed on the same machine, 8.1 and 9, and they ask how to seamlessly switch between them. So you can use, if you send us, if you send tech support at ap.com an email, I could give you some examples, but you can use config files with LabVIEW projects to force the LabVIEW program to use a specific version of a DLL. So if you send me an email, I'll send you some example code to do that. Let's see what else we have in here. Is syntax highlighting possible in MATLAB? I haven't been able to get that to work well in MATLAB. I think because MATLAB isn't the most .NET friendly, so it doesn't do reflection well, at least. And so from my experience, really Visual Studio and the .NET languages are the best, which maybe isn't the most surprising. But yeah, MATLAB, I haven't been able to get that sort of IntelliSense-like functionality to work. Are plugins such as attack and release included in the API? Yeah, so that's that document that I showed in the helpful materials. So if you go to our website and download the plugin API guide, you can control any of our plugin measurements, including attack and release. So yes, that will work. Somebody asks if you can search inside the API browser. That's not currently possible. So you do have to browse through the tree structure. And I will point out, this is one reason I like to use Visual Studio, is because Microsoft has put a lot of work into that IntelliSense functionality. So if you find the API browser a bit cumbersome to navigate, one thing you can do is, even if you don't want to program in Visual Studio, you can use it as a search tool, a sort of sandbox. So that might be something I would suggest. Let me see here. We have another question. When changing signal path setups through the API, is it recommended to use some thread wait or sleep function to wait for the new signal path to finish switching over, or does the API handle that? It's all handled by the API, so there's no need to use any kind of waiting statement. Is this seminar recorded? Yes, the seminar is recorded, and you should get an email with the recording, I believe, as well as a copy of the slides. And you should actually already have access to the slides right now. If you should see a section somewhere in GoTo called Handouts. So if you go into there, you should see an option to download the slides that I just went through. Are all PC AP Connect hardware interfaces only USB, not LAN or serial? That's correct. All of our analyzers are USB connected to the PC. So if you want an analyzer to sort of be network connected, then you'll need to connect the PC to the network and the analyzer to that PC. There's no direct LAN connection. I see a question about using the software, the API with TestStand. So I personally haven't used TestStand, but I do know, actually I briefly have. I do know of customers that are using TestStand with the API. So if you're having issues, maybe send tech support at ap.com an email and I can try and help you with that. I don't currently have a license for TestStand, but in the past I have used it with the API and it does work. So yeah, send us an email and I can help you with that. Okay, we'll do one last question here, I think. Somebody is asking if we have LabVIEW or DLL compiled in .NET 8. I think maybe what they're asking about is if, I think .NET 8 is part of .NET Core. But .NET Core is actually something completely different from .NET Framework, which is not currently supported by our API. So you will need to use a .NET Framework-based application. And with that, Jen, I think we can wrap it up here. Did you have any final comments for us before we close?
Yes, thank you, Ben, and thank you to all of the attendees for joining us today to learn more about the APx500 API. As Ben mentioned, everyone will receive an email with a recording of this webinar along with another copy of the slides. You can find those now in the handout section. If you would like to stay up to date on future online and in-person audio precision events, including the workshop series that Ben mentioned at the beginning of this webinar, please visit our website at ap.com/events. Thank you again for attending, and we hope you all have a wonderful rest of your day.